All right, for example 2, we're given another parabola, but notice here the leading coefficient is negative. So I know that this parabola, before I even graph it, is going to open down. So once again, we want to find the intercepts and the factored form of the quadratic function. So I'm going to go back to my y equals, clear my previous function, and we're going to have negative 2x squared minus 15x plus 42. And then I'm going to zoom standard. And we can see the parabola goes up, comes back down. I can actually see both of my intercepts, but this is kind of riding the edge of the graph, which is okay. But I'm going to go in here one more time, and I'm going to zoom fit just so I can get a better look at the whole thing. And so we can see there's our parabola coming up and going down. So in this view, I think it might make sense to kind of slide our viewer over a little bit so we just can have a little bit better picture of this. So I'm going to go to the window, and once again, I'm going to go negative 15 to, let's say, 5 again. And so there we go. There's our first intercept, there's our second intercept, and now we can find our zeros. So second, calculate, 0. For my left bound, I'm going to pick the left edge of the graph, which is 15. Now, once again, this 0 is on the other side of x equals 0, so I'm just going to put in 0 for the right bound. And now it's going to find that first x value, and that is negative 9.67 when I round it to 2 decimal places. Now we know there's a second one, so let's go in and get that one. So second, calculate, 0. This time I'm going to start at 0 and go over to 5. So 0 to 5. And I get 2.17. So once again, we want to write this in factored form. So I pull down my a value, and I'm going to get x plus 9.67 times x minus 2.17. To find the vertex, well, since my parabola opens down, the vertex is now the maximum of the function. So I'm going to go to second, calculate, and scroll down to maximum. And for my left bound, I'm going to put the left edge of the graph, the right edge of the graph. And I can see, once again, I want to point here, it's negative 3.75. And the y value is 70.13. So the domain is all real numbers. And the range, since the graph opens down, I go negative infinity up to the vertex. So negative infinity, and the y value of the vertex was 70.13, and I include that in my range. So to find the intervals of increasing or decreasing, the function's increasing, right, to the vertex, and then decreasing. So we're increasing from negative infinity to negative 3.75, and we decrease from negative 3.75 to infinity. So once again, when we talk about the intervals increasing, decreasing, or concavity, we want to index that by x values, not y values. The concavity of this graph, well, it's concave down, and I was able to determine that by looking at the sign of A, and then the sign of A told me what the graph looked like. Example 3 says find the maximum and minimum values of this function on the given intervals. So the first thing that I want to do here is, when I look at the first interval, it's negative infinity to infinity. So that's the entire domain of the graph. So this is another way of saying here, it's asking me to find the vertex, because this is a quadratic, right? It's got x to the power 2. So let's go into my y equals. We're going to put our new function in. So negative 0.15x squared plus 3.32x plus 123.62. I'm going to zoom standard. I know it's not going to work, but I always like to start there. And I can't see anything on this graph, okay? So one thing that might help is let's zoom fit and just get some kind of clue about where we are. So if I zoom fit, it's going to adjust the y values. And I can see the parabola, right? Looks like it's coming up to make its turn. So I'm going to definitely need to widen these x values. So I'm going to take these out to, let's see, I'm going to go to like negative 100 to 100 and see what that looks like. Okay, so not quite that far, but this will get it done for me. So now I can actually see where it's going to intersect the x-axis, and I can see the top of the parabola. So if I go to second calc maximum, and my left bound is negative 100, my right bound is 100, it shows me that the max y value is 141.99. So maximum and minimum values of the function, those are y values. What's the biggest y value and smallest y value that comes out? So the maximum y value is 141.99. Now this is a parabola that opens down, so if I'm looking at the entire function, there is no minimum because the function just goes down to negative infinity, so it never really stops. And furthermore, I'm going to write down my vertex. So it's 11.07, comma 141.99. So that is the top point on our graph. Now look at the next interval. It's 5 to 15. So if my vertex, right, 11, is in here, which it is, we already know if that's the biggest point on the entire graph, well then it also has to be the biggest point in this interval. So I already know that my max is going to be 141.99 again. But what I do need to do is I need to find the minimum value, because now, rather than the graph being able to look at all the values, we've actually cropped it at 5 and 15. So the endpoints could in fact be minimums. So if we go back to our window here, we can actually assign these values to the window. So I can say, well, I only want to look at this graph from 5 to 15. And so this picture kind of looks a little funky, so I'm going to zoom fit again. And there we go. So just like we expected, the vertex is there. So that is definitely the maximum. So now we need to find the minimum. So I'm going to go to second, calculate, and I'm going to go to minimum. I could see from the picture that it's going to be that point at 5, but the calculator will confirm that for me. So I'm going to say 5 to 15 as my bounds, and it's going to give me, it's giving me the right side. Let's try that one more time. Minimum, left bound is 5, right bound is 15. Interesting. It's giving me 139, but it definitely looks like this is lower than that. So I'm going to widen my window because it might not include my endpoints. I'm going to take it out one more notch. And let's try this one more time. So now second calc minimum, and I'm going to check it from 4 to 16, and it's still giving it to me on the right side. So the minimum here is 139.67. So I'm actually going to trust the calculator because it is possible the way the calculator is graphing it that maybe that y value, we just can't see it the way that we want. So then we want to know what the max and min are when we only look at the graph from 30 to 40. So I'm going to come in here and crop this same picture from 30 to 40. and I don't see anything. So we're going to zoom fit. So when you check for maxes and mins, it does check the endpoints as well. So that's why it's best to crop it on the actual interval you were given. So now when I do second maximum, my vertex is not in this interval, so I have to check it. So let's see, we went from 30 to 40. And we get the maximum at 30, so it did check, it grabbed this guy, and that maximum Y value is 88.22. So the max is 88.22. To get our minimum, we're checking from 30 to 40, and it's at 4016.42. So I wanted to make a note here. So notice in our first two intervals that our maximum value was the maximum for the entire function. So if this is in your interval, then the vertex is the maximum. Similarly, if we had a parabola that opened up, the vertex would be the minimum, and if this value was in any of the intervals they asked you to check, then the vertex would be your minimum. So it just kind of can save you a little bit of time, and it can also help you create a checkpoint for yourself. If you actually tried to find it in the calculator, that value would in fact come back up.